Find the average rate of change of f of x equals negative 2x squared minus 3x from x equals negative 2 to x equals 2. Now the average rate of change, remember, is essentially asking you for the slope. So this is like asking for the slope from x equals negative 2 to x equals positive 2. And because I want to make a graphical connection here, I just want to remind you that if we look at the graph of this function, negative 2x squared minus 3x, that's going to be a downward facing parabola of some sort like that. And we're basically saying we're wanting to go from x equals negative 2 to x equals positive 2, wherever those values are, and we're finding the slope of this line that cuts through the parabola. And for those of you that are headed to calculus, you'll learn that this is called a secant line. Now understand, I didn't actually graph this accurately. I just am giving you a rough sketch so that you know what this is going to basically represent, where the average rate of change is just the slope of this line that goes from x equals negative 2 to x equals positive 2. So think about having ordered pairs. We have x equals negative 2, but we don't know the y value. And then we have x equals positive 2, and we don't know its y value. So we essentially need to take the x values that were given, negative 2 and positive 2, and plug those into the function so that we can get the corresponding y values. So that means we're really going to be finding f of negative 2. That'll be the corresponding y value. And then we'll also plug in 2 and find f of 2, which is the corresponding y value for the input x equals 2. So I'm going to do that off to the side here. Let's start by finding f of negative 2, which just means we are basically plugging negative 2 into our function here in place of x. So that's going to be negative 2 times the quantity negative 2 squared minus 3 times negative 2. Then remember, order of operations, it's really important that we always do the exponent first. So make sure you abide by order of operations here. So negative 2 squared is positive 4. Then negative 3 times negative 2 is positive 6. And that gives us negative 8 plus 6, which gives us an output of negative 2. So when x was equal to negative 2, the output, the y value, actually was also negative 2. So now let's do the same thing, but this time we're going to substitute in an x value of positive 2. So that's negative 2 times positive 2 squared minus 3 times positive 2. Exponents first again. So 2 squared is positive 4. Negative 3 times positive 2 is negative 6, which gives us negative 8 minus 6, which ends up being negative 14 as our output. So when x is positive 2, our output is negative 14. So now we have our two coordinates, and now we want to compute the slope between these 2 points. And remember, slope is the change in y divided by the change in x. In other words, we want to look at the difference between the y values and the difference between the x values using that slope formula. Now, it does not make any difference which y value you start with. So, for example, if you want to start with the y value of negative 14, that would be fine. So then the change in your y values would be negative 14 minus the y value of the second point here, which is negative 2. So that's negative 14 minus negative 2. And then since we started with negative 14 as our y value, it's important that we start on the bottom with its corresponding x value. So that would be positive 2 minus the corresponding x value here, which is negative 2. So that's 2 minus negative 2. So that turns into negative 14 plus 2 divided by 2 minus negative 2 is positive 4, which is really negative 12 divided by positive 4, which gives us negative 3 for our average rate of change, which is our slope. Now, I just want to mention, because I know some of my students get confused regarding the order. So let me erase this and just show you if we had done this in the reverse order. So let me switch now and show you what would have happened if instead of starting with negative 14, we started with the y value of negative 2. We are going to still get the same answer. So if my y value is negative 2 for my first coordinate minus the y value of my second coordinate, which is negative 14, that's negative 2 minus negative 14. And then since I started with negative 2 as my y value, in the denominator I should start with the corresponding x value, which is negative 2. So that's negative 2 minus the corresponding x value here, which is positive 2. So if we compute that, negative 2 minus negative 14 is really negative 2 plus 14, all divided by negative 4, which gives us positive 12 this time, divided by negative 4, but that still simplifies to a slope of negative 3. So my average rate of change is going to be negative 3. And if I go back to my diagram, what that just means is this secant line here, the one that I drew, had a positive slope. So in reality, if we really took some time to graph this, my secant line must have a negative slope. So my secant line would be pointing down, and the slope of that line essentially is negative 3.